Okay, over here we have Amy with a few tanks, including some open tanks. You can actually see what they look like on the inside. I guess, yeah, how are these basically constructed?
Yeah, so what you see here is a cutaway of a Mirai tank. So this is the plastic liner. These are what we call type 4 tanks. So
Okay.
what that means is they are plastic on the inside, and that keeps the gas inside and not leak. And so what happens is this is actually injection molded into a carbon fiber overwrap. And so
Nice.
this is the carbon fiber, and that provides the strength to the tank. And then on the very outside, we can see this. Oh, this is a better example here. Is the glass fiber or glass overwrap layer. So that's kind of a shiny, smooth
Okay.
layer. And so you don't want, it's just for protective purposes. It's not load bearing. And then on the side, we have some tank dome protectors from drop, and they also help with fire resistance. And on each of the tanks, we have valves, and that can probably be seen better over on these displays here. And this is the valve for the tank. So it includes this is what we call the on-tank valve. And so when the hydrogen is fueled from the station through the receptacle, it goes through these tanks or into these tanks. And we have 3 tanks in the Gen 2 Mirai. So starting with the big one, this goes along through the center column of the Mirai second generation Mirai vehicle. The number 2 tank and the number 3 tank, they're all similar designs, type 4, with the valve and the end bosses. And these tanks have been tested rigorously to withstand a 20-year service life.
Okay.
And they're tested in all the ways that you can think of.
Yeah.
We drop them, scratch them, put them in fire,
Wow.
gunfire, everything.
So
they
they're
are
like guaranteed for 20 years, but sounds like they might last longer.
a lot longer. That's what I'm thinking.
Nice.
Yeah,
I guess what is like the safety questions that come up? Like people are wondering like, oh, like pressurized, they get scared of that whole term. But I mean, assuming it seems like, carbon fiber is a super strong material.
Yes.
So that's like the actual structure of the tank.
Right.
And like you said, the plastic is what contains the hydrogen.
Correct.
And then this is like protecting the protective part, or I guess the structural part.
Yeah.
Yeah.
The glass fiber actually doesn't hold any. It's not weight bearing or pressure bearing. But these tanks are tested to withstand multiple fuelings, because that's what that's cycling. Puts stresses on the inside of the tank. So we put it through many cycles of complete fueling and defueling with hydrogen gas, different temperatures of hydrogen gas, different external temperatures. We test really cold, so that's like minus 40 C,
Wow.
which is minus 40 F, I guess, at that point.
Yeah.
And 85 C, so that's 120 something degrees. So we tested in all the most rigorous or extreme temperatures that you can think of.
Okay.
There's also safety. These tanks work in conjunction with the other safety features in the vehicle, like the hydrogen sensors that are in the vehicle that detect any type of leakage and will basically, shut off the hydrogen supply, the valves to the tank, and alert the driver. So
Nice.
There's multiple ways that we prevent or keep drivers and passengers safe in a hydrogen vehicle.
Okay, and these are kind of the smaller, like consumer vehicle tanks, and then these over
That's
here are these
right.
like the bigger commercial ones?
Yeah, so basically they look the same if you just look at it.
Yeah, just
they
blown
are so they're the same design, and they're qualified to the same stringent standards that our light duty vehicles are, and they are just bigger tanks. So we're using them in the large trucks that you can see behind us.
Yeah.
But they have the same safety features, the same, all the safety features that you would expect.
Okay, and it's really kind of a scalable design. I mean, you could build like, in theory, super big ones for crazy
Absolutely.
big
Yeah, have you seen
purposes.
that guy?
Yeah. So what would that be used for? Is that just another
Yeah, that's just going to demonstrating another, that can go in a truck, it can go in multiple, any kind of mobile
Yeah.
application at this point.
And a sweet little forklift from Japan, I guess.
Yeah, so that's a hydrogen fuel cell powered forklift.
Awesome.
This was used in our one of our plants in Japan to move things around. So
Super
the
cool.
applications are
Endless.
are
sort
very
of. Awesome.
gone beyond the Mirai here.
All right, outside of the main floor area, we have this kind of garage playground in here, and Andrew, who's a principal engineer over here with Toyota, and yeah, a Mirai up on a lift with some underplating removed. So what happens in this garage space?
Yeah, so this is our hydrogen garage. It was specially built for us to test and to develop new hydrogen products, and even some prototypes that maybe won't even make it to production, but we can, like you said, it's a playground. We can test different things.
Nice.
The garage itself was built with all the ventilation, all the safety, all the sensors for hydrogen detection, hydrogen leaks, and we really play. So for safety, this is the best place to do all of our hydrogen work and development. On the lift, we have a second gen Toyota Mirai with our teammate level 2 autonomous technology. So that's why you'll see some of the LiDAR and radar sensors around this vehicle. And we did take the plates off of the bottom, so you can very easily see our hydrogen storage in these 3 tanks. You can see the electric motor, the battery, and the fuel cell. A little bit more difficult to see, but this is not a view that we usually get to show people. But you can see all of these hydrogen lines, some of the high voltage cables, and it is a electrified vehicle with an electric motor, and like a conventional vehicle, you can fill it up in about 5 minutes. It fills up with hydrogen gas,
Yep.
5.6 kilograms in these tanks, and then it has an air intake. And where the engine would be, we have the fuel cell system. So with that chemical reaction between the air and the hydrogen, we're generating electricity, which can be stored in the battery or used at the motor.
Yep. That's very cool to see. And yeah, not a view we usually get. And I guess this is where the exhaust is, which is actually just water vapor? Or...
Yeah, so you have hydrogen, you have oxygen, and when they come together, they make H2O, and that's all you get out of the tailpipe.
Nice. Very cool.
So we have a couple lifts in this garage. This one, we have one over there and one over there. So we do work on vehicles, some prototype vehicles, and the Mirais as well, of course. But we also work on the fuel cell stacks themselves and some stationary projects. So you may have seen outside we have a fuel cell generator, which can power a stage, or even be backup power to a building, or be part of a microgrid, such as at the NREL laboratory in Colorado, which is what's being shown on the TV screens over there.
Awesome, yeah. So I live 5 minutes from that facility on the screen right there.
Okay, great, yeah. So they've
Colorado.
integrated our megawatt fuel cell generator on their microgrid over
cool.
there. And most of that was tested and developed here. We had 4 fuel cells running at the same time over here. And it's the first time that we've done that. You've seen on some of the heavy duty trucks, we have 2 fuel cells running the heavy duty trucks, but over here we're using 4 fuel cells all at once. And then now we call them a quad, and we can use those quads and stack them up to like the megawatt system that we have over in Colorado. But we also worked on the generator that was outside. We worked on the TRD generator as well, and a lot of that work was done here. Being our playground, we have various parts. We have our electrical bench. We 3D print things. We mill things. We make all kinds of parts that we might need during our testing and prototyping.
Nice. And I saw this big electrical line coming from the wall over here. Like, what was that used for exactly?
Well, when you're running 4 fuel cells all at once, you generate a lot of power, and you need to dump that power somewhere. So we have things like a battery emulator, so we can emulate a large capacity battery, and sometimes we have to dump power, so that's a very big
Nice.
power plug that you see. And you'll see some other similarly big wires at our dyno that's over there, the 1.2 megawatt dyno, where we also test a bunch of components, even the full heavy duty vehicles
Very cool.
systems.
And I guess for the tanks in the Mirai, are those like, I know it's like 5.6 kilograms. Is that like, are the tanks running sort of a parallel or like a series situation?
That's a good question. In those terms, I would say parallel.
Yeah.
They basically act as one tank. And what
Okay.
you'll see here is the manifold. So you'll see all 3 inlets going to one manifold, all 3 outlets going to one manifold. So when you fill up, it's filling up all 3 of them at once.
Yeah.
And when you're using it, it's depleting all 3 at once.
Okay.
So we're not individually managing them.
Yeah. And so the idea of having 3 tanks is really just to allow you to spread out the hydrogen throughout the car instead of having one bigger tank that's like hard to package?
Yeah, it's really a packaging thing. So we put them where they fit.
Okay.
You could, using these manifolds, we could add more tanks.
Yeah.
But you just have to find the space for them.
Gotcha.
Or you could use one big one, or you could use 6 very large ones.
Like in the trucks, yeah.
Yeah.
Super cool. Yeah, this looks like a fun playground. I'm a little jealous. My garage at home is nowhere this size.
Yeah, neither is mine, but at least I get to come here.
That's awesome.